So just to give some background of who I am, because I've got you for the next 40 minutes or so. I'm from Dublin in Ireland. I studied in Trinity, worked at Google for about 7 years. I ended up being the monitoring guy because in order to administer systems, I need good data, which means I ended up fixing the monitoring. And also, been involved in open source for many years. And these days, I'm one of the core developers on Prometheus, and also have a company doing consulting and support around that. So I'd just like to, as it's in the talk title, talk about what Whitebox Monitoring is. Because we'll first look at the opposite, which is Blackbox Monitoring. So Blackbox Monitoring is, well, you're treating the system like a black box. You're talking to the outside and seeing, does it work? So your classic examples are like sending a ping, doing a HTTP request, or dropping data into your pipeline and waiting for it to come out the other side. So the way I see Blackbox Monitoring is it's like a smoke test. It's great for telling if things have gone hilariously wrong. But if you're trying to use it for any sort of granularity or testing every single feature and every single combination, it turns out not to be too great. Because it's so binary in its output, either it works or it doesn't work, they tend to be very flaky. And flaky alerts are bad alerts. So don't use it like regression testing, use it like a smoke test. And to catch the edge cases you just can't catch with Whitebox Monitoring. Because Whitebox Monitoring is complementary. Okay, it's looking inside the system, getting stats from inside, like just Paul was talking there, that whole internal table. That's all Whitebox. So you're getting like your CPU stats, your business metrics, all that sort of thing. It could be CPU usage, it could be requests, and it could be like just one particular code point that you were tracking data from. So in this context, we have Prometheus, which is a Whitebox monitoring system. It's inspired by Google's Borgmon monitoring system. It was started in 2012 by some ex-Googlers, because when Googlers leave Google, they reinvent Google technologies. It's a thing. I've personally worked on, I think, 5 or 6 such projects. It's written in Go, release 1.0 this year, and we're incubating with the Cloud Native Computing Foundation. Now, we are an open source project, so it's very hard to tell how many users we have. Like, we don't have a tracking thing currently inside the binary. I figure over 500 companies are using it in production. But it's very hard to tell. Like, I think I found 2 new companies just talking to people at the party last night. So that's the way it is with open source software. So I'd also like to address the question of the word monitoring. Because if you talk to different people, especially people who are used to like the Nagios style of monitoring, they have a very, very different definition to other people. I've even had people, like, when I'm going to business events and so on, when I say monitoring, mean that they think I'm the person, checking if you're accessing Facebook at work. So it turns out the word monitoring has no clear definition at all. So I just kind of want to try and come up with a better definition, so we have at least some shared ideas and know the sort of things you should be considering at least in your definition. Because I think that there are basically 4 things when we're talking about computer monitoring, the sort of stuff we're having in this conference. Knowing when things go wrong, or commonly called alerting. Debugging that problem. Trending more long term, and then, well, plumbing, which isn't really monitoring, but people always do it. So to start off with, when people say monitoring, often they just mean alerting, which is a very limited way to look at things. But the question then about alerting is, what is exactly the wrong thing we are trying to find, right? Is it some small blip, or is it an actual issue that's affecting users and costing the company money? And it's important to consider this, because fundamentally we're humans, we're engineers, we're expensive, and we need sleep. An engineer without sleep is not a particularly productive engineer, and they're likely to burn out and ultimately leave. So you need to think and decide, what are you actually going to alert on? So let's say that you care about end user latency, because that's normally a sort of thing you want to hear about. There are hundreds of things that could cause a problem with end user latency. You could have a dodgy network, you could have a DOS somewhere, you could have a deadlock. You could try to alert on every single one of those, but you're never going to catch them all. And there's always going to be weird stuff you could never have imagined happening. But what you could do is instead just alert on the symptom of, hey, the latency's high. And in which case, that's going to catch all the weird cases, or at least almost all of them, automatically. And it doesn't require as much maintenance. And it also means far fewer false positives. So there are systems out there that basically don't allow you to alert on latency. Like for something like Nagios, it's very difficult to do that out of the box. You'd have to plumb it through via graphite or something. You can make it work, it's annoying. But so you do have those CPU usage. And you can alert on that, like, hey, 80% CPU is used. That's going to have a lot of false positives. Like if someone tells me that 80% of my CPU is used, I'm like, great, I paid for that. It's nice that it's being used. In fact, why is it only 80? You know, what happens to the other 20%, you know? But if you're alerting on that, you're going to get false positives because log rotate ran long, and false negatives because, well, that's going to spawn a deadlock. Because if you've got a deadlock, CPU usage goes to 0. You know, so it's not great. So the end result is you can end up with spammy alerts for things that don't matter, and whoever's on call ends up ignoring it. If you're ever in a situation where you get an alert, look at it and go, meh, go back to sleep, you're in a really bad situation called, you know, pager fatigue or alert fatigue, and you know that's quite difficult to recover from. So false positives in alerting are really, really bad, and you want to avoid those. And this kind of gets to a general point when you're looking at alerting and so on. Lots of people are just looking at the outside of the system, and there's a whole pile of stuff going on inside as well. It'd be kind of nice to know about as well. It's like, yeah, HTTP requests are going okay, but we've got no idea what's going on in here. So just as a way, if you've got an architecture, a microservice architecture, you've got lots of services talking to each other. In the same way, all the libraries are kind of like services inside your single process. And you should be instrumenting them in the same way. You've got your query rate, you've got your error rate, you've got your latency. And you should have all of those and instrument them. And then expose them to something like, say, Prometheus, which will bring that out together, or whatever other monitoring system you have here. And beyond that, we shouldn't be thinking about machines anymore, right? This is the pets versus cattle thing. We're talking about services. If I have 100 machines, and one of those machines is outside of SLA, but the overall service is still within SLA, there's no reason to wake up a human. Human time is too valuable for that. And you should be trying to think in those terms, right? Individual machines should not matter. Of course, that'll never actually happen, but you know, it's good to have ideals. So the system like Prometheus, like it's designed to do whatever alerting you would like. So if you want to get an error ratio across all the machines in the data center, no problem. 95th percentile, you know, how long is the data taking, and also the black box probing like FIPS, like are you giving the right responses? Because the thing is, what you want to do always, whatever monitoring system you are using, is have alerts that require intelligent human action. If it's scriptable, then it shouldn't be going to a human, right? And here's actually just the alerting architecture of Prometheus, because we've got something else interesting that we do, is that Prometheus itself doesn't talk to things like PagerDuty. Everything actually goes to the alert manager, which groups things together. Because you can imagine, if you have machines down all on the same rack, do you really want to get 40 alerts? Or would you like one alert that mentions, by the way, here's these 20 things or these 40 things that are down? So grouping is very useful for just reducing against that ideal of having one notification per incident. Which, once again, it's not something we're ever actually going to achieve, but we can get close. There's also our HA approach is just run two Prometheus servers, and the alert manager will deduplicate. So it's a quite simple approach that we take. This is quite nice. So the second thing that we have for monitoring is debugging. Because, OK, you've got your page. It requires intelligent human action. It'd be nice if we could actually do that intelligent human action and figure out what that is. So you need dashboards. You need ways to debug, right? Because if someone says, hey, your system somewhere is slow, right? You need to go from there and walk your system and figure out where the problem is, okay? Because you need to start at the top of your stack, look at the back end, see is it overloaded, and just walk it down. So there's lots of dashboarding options out there. Prometheus has several, including Grafana, which is what we recommend. It's important as well that you're getting data from every level of the stack. Right? You can't just be looking at the very front of your system. You need to get your MySQLs, you need to get your middleware, your routers, everything. You need all these things. So Prometheus has a ton of integrations, including Minecraft and Factorial. Yes, very important, yeah, they're there. But also other monitoring systems. So like if you're using already Grafana, Statically Collecti, you can actually get those data into Prometheus. Because let's be honest, the dream world where everyone uses Prometheus for everything is unlikely. So we have to be, think about the real world and just try to consolidate down so you have the option of keeping things simple. And these are all pretty easy to write. Like most of those were created about the core development team knowing about them a little after they were announced. And the other thing though is to mind that Prometheus is a metrics whitebox monitoring tool, but it's just one tool. It is not the be-all and end-all, right? You need multiple complementary tools to actually do things in reality, because there's no silver bullet, as was stated yesterday, and there's different problems, different trade-offs. and it's important to have these because there are limitations. In reality, when you are debugging, you're going to need a mix of metrics, logs, profiling, and source code. Because your metrics, they're good to tell you that, hey, things are slow. And it's okay, it's probably this server. But they're not going to tell you, but it's this customer. You need to look at logs for that and figure out, okay, why is it going slow? Which piece of code you need to pull out your profiler? And then you look at the source code and go, oh, I see what's going on. So as you're debugging things, there's an interplay between all of these things. So it's important that you actually have logs, metrics, profiling, and source code so you can put these together when you're on call and put it together. If you've got tooling to help that, it's great, but just one of these tools isn't going to work out because it's going to miss classes of problems. So the third thing that I think monitoring is around trending and reporting. So alerting and debugging, those tend to be on the order of minutes to hours, maybe days. Trending and reporting is weeks, months, years, because you're looking at long-term changes over time. You're trying to do prediction for capacity planning, or maybe you're just trying to make a business decision. It's like, hey, that cache hit rate's going up. Maybe that means we can get rid of some hardware, or maybe we can increase the number of things that are in the cache key and give users a better experience and make that sort of engineering decision about it. Because the thing is, Prometheus as well, we can go beyond this. So the query language is pretty powerful. You can slice, dice, cut, whatever you want. And yes, you can figure out 95% latency. But another thing as well, that static disk thresholds, whether it be in terms of like a gig free or 80% used, have problems because each of those doesn't work on one of either large disks or small disks. Because if you have 1 gig free on a 2 gig disk, well, that's always going to fire. And if you have like 5% free, or at least 10% free on a 1T disk, where you're going to be wasting 100 gigs of space. What you can do, though, is actually do a simple linear prediction to figure out, hey, this is going to fill up in 4 days, and then alert on that. And that tends to be better. It's not perfect, but it's a smarter way to look at it. An example then of just sort of analytics. So this is an actual query. If you're using CAdvisor to get Docker stats, you can run this query then in your Prometheus. So what this is saying is get CPU usage of all the Docker containers and sum them by image. That's ignoring machines, clusters, services, any other thing. It's just looking at the name of the Docker image and giving you the top 5. So this could find the 5 Docker images that you might want to optimize how they're built, just to save yourself some electricity. That's just a simple example of some of the analytics you can do. Most queries are actually quite a bit simpler than this. And the other interesting thing that we have, and this is thankfully something that's become more popular, is that Prometheus has labels. So those of you who use the graphite has dotted strings, which has some disadvantages. So one of them is that sometimes people put a dot in the middle of the value, which completely breaks the hierarchy. People, escaping is important. For standardization, I don't care which, do not put dots, because dots are significant in graphite. And the others as well, it's like full UTF-8, which is kind of handy. But also because these aren't ordered, we can slice and dice whichever way you want on them. And we actually know what these mean. Because NYC, would you guess, is aircraft carrier location? You normally think that's going to be cluster name, but no. I changed it before, just before. And the thing is, well, these can come from the actual service, because the service itself knows that, oh, right, this is a 400. But only you, as the administrator, know, yes, but that's the dev cluster. Because a random process doesn't know what's inside the dev cluster. So here's some example here of some network stats. So this is a Docker machine. You can see ETH0. Here's the instance ID and the job is node. So you can have many of these. You probably won't have too many because you run into performance issues. And as well to actually use these, because it's important, it's great to say, hey, all these metrics, but you need to actually, at the end of the day, add them to your code. So we try to make that as easy as possible. So this is a complete example of Python instrumentation. So you install the Python client, define your metric here, and then just use it using a decorator. And that is enough to time that function. And then we start a HTTP server, so Prometheus can pull for it. If you want to add some dimensions, labels, tags, it's just a matter of saying, here it is, and you just specify it. So that's another 15 or so characters, and you have labels. So just try to make this as easy as possible for users. And as well, like labels come from other systems. So if you're using something like Kubernetes, because it is a similar data model, we can pull those all in. So if you've got pod labels or whatnot, those can be just automatically pulled in Prometheus. So one of the other core developers, Fabian, is working a lot on with the SIG instrumentation to kind of clean up Kubernetes as well internally as instrumentation. So the final thing that you have for monitoring is plumbing, which is not monitoring. It's just, well, when you have a hammer, everything starts to look like a nail. Sometimes it's just convenient to use your monitoring system to move data from A to B. And people do that. So when you're choosing a monitoring system, you should be looking at what the integrations are like in terms of getting arbitrary data in and getting arbitrary data out. Because just sometimes that's convenient, even if it's not what you should really be doing. But if your choice is between spending a quarter developing an ad hoc system or sending 4 bytes of data through your monitoring system once a minute, that's not a hard choice. So actually, one of the interesting things we have in Prometheus is we try to be an open ecosystem. So for example, that Python example I showed you, at the end, it was providing the metrics in Prometheus format over HTTP. But you could also, with 2 lines of code, have told it to write that data in graphite format as well. So the client libraries are completely separate from the actual Prometheus implementation. So you can also parse the data, and you could send it out, grab the data from CAdvisor or whatnot, and spit it out to graphite. Or there's a monitoring system called Zmon from a company called Zalando. They're a clothing company in Europe. Basically, it's a Python Nagios that's scalable. But they're actually using, I think it's CAdvisor, which the Prometheus client library, parsing those stats and then putting it into their own monitoring system without actually running Prometheus itself at all. Because one of the things that really kind of annoys me as a monitoring system author is how all the other monitoring systems have to reinvent the wheel continuously. And how do I monitor MySQL? How do I monitor Postgres? How do I monitor Redis? How do I monitor JMX? At least if you can reuse all our libraries, we can then focus on the important questions of, OK, now that we've got the data, which of it's important? Because that's the real question we should be focusing on, not arguing over plumbing. And now, the bit that everyone loves, the live demo. I'd like to, yeah, cool. So running Prometheus, it's a simple matter. Go to Prometheus.io. You go to the download page. There we go. And we can just pull down Prometheus here. And the node exporter, there she is, which is our machine agent. So those are downloaded. So let's just run, for example, node exporter. Yes. Most impressive web page ever. Yeah. It used to have that page. It used to be a 404. Yeah, because it's not actually relevant. Here's the real thing. Okay. So here we've got some internal Go stats, which you get for free. You can see some labels here from quantiles. And here's some memory stats. This is all internal just Go stats from Node Exporter itself. There's about 40 of these or something. And then we get on to the real stuff. So here's the CPU stats here. You can see it's broken out by CPU and mode. And this laptop has 4 cores in it. That's the stat. Disk stats, let me just make this smaller. This is your file system stats, memory stats. There's about 100 of those. Network stats, network stats, network stats, network stats, network stats, socket stats, slightly different. And VM stats, so a slightly different type of memory stat. Anyway, we've got about 400 or 500 of these. As the sort of stuff you can just get by trolling /proc and /sys. But that's nice and all, but it'd be good if we could actually do something with it. So let's actually run a Prometheus. Okay. 5 seconds. So this config here, what it's saying is scrape every 5 seconds, scrape the Prometheus itself, because Prometheus exposes Prometheus metrics, and scrape the node exporter on port 9100. So this is a pretty small and minimal config. You can actually make it a little smaller. Cool. And that's now running. There it is. Isn't that wonderful? So as the your standard debug stuff, it's like, yep, it successfully managed to scrape them. There's no rules because we haven't kept things simple. Check out all the configuration, check the build information. Like this was built about a week ago. Then we've got the graph page. So like we could visit up, and it sees that, yep, both of these are up. They're working. Or if we look at our friend, we were looking a second ago, node CPU. And there it is there, all those stats. And we can even graph that. Okay, so let's just go down. This is always the fun bit. Okay, a little smaller. Yeah. Of course, the thing is just like 60 or so lines on that graph. And this is since the laptop rebooted, whenever that last was. So that's not too often. So what we really need to do is get the rate of that. Okay, so let's do 1 minute. And now we can see how fast that's going over time. But yeah, this needs to be a little smaller. But that's still not particularly useful because we've still got all of those entries. It'd be nice if we could aggregate that up. So what we can do then is, let's ignore the CPU. Sum it out, CPU. So simple aggregation, we can make it a stacked graph. And now we can see that most of the CPU is idle, unsurprisingly. We've got a bit of system and a bit of user time, as you'd expect. So that's just, this is the ad hoc interface for expression browsers. It's not what you use in production. You use Grafana. There's also some built-in consoles as well. But I will move on to Grafana, which I've prepared earlier. So here's the stats for the Prometheus itself. Obviously, it's only been running for a few minutes. So it's currently only got like 1,100 time series, so not too many. You can see all the graph requests we're making. The memory is up to, the sides cut off. It's up to about 70 megs of RAM. And it's only pulling in like 240 samples per second, which is pretty small. Like my home one does more than that. I was just to show some of the Grafana-related features. So like one of the things we export with the latest versions of Node Exporter is temperature, and it's by chipset. So in fact, this is using the templating feature with repeated panels of Grafana, so that this is automatically adding in those graphs based on the labels. So you can see here's the chip, and it's using a repeat panel. And you can see up here that there's a template here on the chip. So we're basically running that query to get a list of all the different chips that are inside this, reporting temperature stats. Oh, that's just doing. Get me back. Another feature was added recently. So Prometheus is all numbers. Okay, everything's a float 64. But because we have labels, they're kind of strings. So you can cheat and actually get strings out. So it's actually reporting the version of the node exporter there from the label. And other things you can do as well. So this is actually an example of prediction here. So we've got a table. And it's actually predicting that, well, nothing's going to fill up soon. But it can actually predict how fast those file systems are going to fill up. Yeah, nothing's going to fill up here anytime soon. That's just an example of some of the things you can do. Probably. Yeah, the problem is I can't never get results that actually say like 2 days or something. It's a problem with working with real world data on a laptop. The other thing that might be interesting is there is a live demo of Prometheus and whatnot on demo.robustperception.io. So you can play around with everything I've shown here. And we've also got this because the Prometheus query language is quite powerful. Yeah, this is using like half a core to run this. And it's Web 1.0, the latest and greatest, HTTP meta refresh. Yeah, I've yet to see a glider, which is annoying. No one this time. Yeah, don't do this in production. Very expensive. Yes. So I can honestly claim that there is no monitoring language more powerful than Prometheus' one. Okay, so just to summarize then, the things that Prometheus allows you to do, and to be honest, no matter what monitoring system you're looking at, you should be looking for these things, because let's be honest, there's lots of options out there. You want to alert on symptoms and have alerts to require intelligent human action. You want to have debugging dashboards that let you drill down into the problem. And you want to, slice and dice, be able to do some analysis, as well as having plumbing, because sometimes you just need to get data from A to B. And I'm going to share with you like 10 tips for monitoring. Now, these are not Prometheus specific at all, but just other things that you should be thinking about. Because when you start getting seriously into time series monitoring with an efficient system like Prometheus, you're suddenly, like as mentioned in the previous talk, if you've got 1,000,000 time series, you're going to have fun dealing with that. So how do you scale up the way you think about things? Because like the approaches you can use for 3 machines do not work for 30 machines. So here's some tips. First, as I mentioned, choose your key statistics carefully. Align them with what the users actually care about, not merely what you have access to. So that's looking at latency, error rate, propagation delays, rather than CPU and memory. All right? And those are also the things you should have in your dashboards and what you should be focusing on. The second one is, well, use aggregations, right? If you have 10 services, each running on 10 machines, and you want to graph all that, that could be like 200-300 lines in the graph. That's not readable by a human. What you can do, though, is if you've got just 10 services aggregated and graph those, that's about usable by a human. And once you figure out which service is broken, then you can look at that service and look at it by machine to see if one of them is dodgy. So think in those terms, how do I scale things up, add an extra step rather than just try to dump all the data I can onto dashboards? Which brings me to point 3, avoid the wall of graphs. So dashboards tend to expand over time and grow a lot of cruft. The worst one I saw personally, and this was actually designed like this from day one, had over 600 graphs on it, on a single dashboard. So this has a few problems. One is it takes 5 to 10 minutes to load. The second is, in an emergency, good luck with that. How do I know where I'm meant to look? You know, it's like, having data is not the same as having information. You want to just think about, how can I organize my dashboard so I can logically go through it, right? As I said, your services are probably a tree, so organize things so you can walk things down. It's like if you've got high latency, you look at the root of your tree, see, is this service overloaded? Has one of its backends gone slow? Ah, that one has. Go down to that service, do the same. Is this one overloaded? Nope. Has one of its backends gone slow? Ah, that one has. Oh, right, it's this service here, it's overloaded. Then start debugging that service. If you instead look at all your services and all your machines at the same time and pray that you can spot the spike, you're just going to waste your time, and you might go down, following red herrings. Something else, getting to a little math. Client-side quantiles are not aggregatable. It is not mathematically possible. Sorry about that. Don't try. If you actually want meaningful quantiles that you can aggregate across machines, what you need to do is have histogram buckets, aggregate those up, and then calculate a quantile on that. So in Prometheus, we've got histogram, quantile, and rate to allow for that. But generally, you cannot work with quantiles. Min and max you can make work, nothing else. The other one is, speaking of quantiles, is that averages are actually really easy to reason about. So here's a pop quiz for you. You've got a service, simple service with 2 backends, and the 95th percentile on the root goes up due to one of the backends. What will you see on the 95th percentile of that backend? Any guesses? This is the correct answer. You have no idea whatsoever. Because the thing about the 95th percentile is you're basically throwing away 95% of your data. And unless all the latencies between the 2 services are completely correlated, weird stuff happens. And this is extremely hard to reason about, especially in an emergency at 3 a.m. when you've just been woken up in the middle of the night. On the other hand, with an average, if the root latency has gone up by 10 milliseconds due to the backend latency, you can be pretty sure the backend latency has gone up by between 9 and 11 milliseconds. So averages are handy for basically debugging down and drilling because they work the way you think they work. Quantiles, yeah, you might need to sit back and do a heat map or something and graph the surface and, you get some statisticians in. That's not what you want in an emergency. So, have your quantiles. They're good to have at the borders of the system. But just for drilling down, averages are kind of handy and cheap as well. Which brings me to the general question of cost. Now, as was mentioned once again yesterday, there is no silver bullet. 1 second resolution monitoring of everything would be awesome, except for your wallet. Now, if you have a nice large wallet, I'm happy to help you with that. But in reality, we need to make trade-offs. Is 1 second resolution monitoring 10 times more valuable than 10-second resolution monitoring? The answer is no. It's, 20, 30% more valuable? So you need to make a trade-off there, say with 60-second monitoring. And as well, would I prefer to have this one metric 10 times more granularly, or just have 10 metrics from different parts of the systems giving me a broader overview? These are the sort of trade-offs you should be thinking about, right? Because monitoring is not free. It costs resources. It costs humans to scale up the systems and deal with it, okay? So, just try to think about these things and remember it costs money and time. Also, once again into math, the Nyquist-Shannon sampling theorem. Short version is if you are scraping every 10 seconds, you can only spot features, which is a technical term, that are 20 seconds long. If you ever get a situation, and you actually notice a lot in graphs, you refresh, like half a second later, and the shape changes, and that's because you're running into this. So if you've got a higher frequency pattern than your scrape interval, basically, weird stuff starts happening. You could try increasing your scrape interval, but to be honest, at that point, you need to go to logs, because weird stuff's going on. That, to be honest, a metric system is never going to capture, unless you want to throw a lot of money at it. So just watch out for that. Another thing to be aware of, because we are all human, we're all subject to biases, is that humans are really, really good at spotting patterns. Yeah, like Jesus and the toast and so on. Patterns that aren't actually there. And this can be a problem when you're debugging. Right? And so, it's easy to get caught on red herrings. So always kind of look for some evidence that will falsify your hypothesis. Right? If you see that, hey, these two metrics are correlated, come from the same server, maybe they're related. Maybe it's just pure chance that they're happening at the same time. So don't just look at that one instance inside the last hour. Look past the last week and see, are they correlated for the entire week, or is it pure chance? Or maybe what's happening is that this is some background task that's running, and one of them is causing slightly more lock contention that's affecting the other, and it's just pushing things over the edge. Can also happen. But just because two things correlate once on the graph does not mean anything. You need to look over a longer time period and see, does it bear out? Another one to be aware of is you do need to know the difference between logs and metrics. There are trade-offs between them. Each of them has their strength. Each of them has their weaknesses. So the great thing about logs is logs have information about every single event. And that's really handy if you want to figure out what's going on. But it does mean that bandwidth and disk space limits you to, let's say, 50 to 100 fields inside that log entry. Metrics, on the other hand, they aggregate across events. So you're losing that per event information. But because you're doing that, you can have like 10,000 of them. But it's a really bad idea to split it out by IP address, because that messes up your cardinality. So how I would recommend using it is metrics are great for the high-level view and figuring out which system is to blame. And then you use logs to figure out, OK, now we know which system it is, which request is it now? And have that sort of interaction between the two of them. Because, as I said, you need more than one tool to debug real-world problems. And finally, going against the human factors, it's important that you have a way to deal with non-critical alerts. How many people are receiving at the moment, say, over 100 email alerts a day that they're ignoring? Yeah, I can see the guilty faces. Because what happens is, it's like, this thing's important, but it's not important to wake someone up. So what we'll do is we'll email the team list, whereupon everyone who's smart will set up a filter to make that alert go away. And then the outage happens, because there's always an outage, and people are asking, but the alert told us, why did no one look at it? It's like, yes, somewhere among the 100 or 1,000 emails I receive a day, there was an alert that indicated a problem. But the signal-to-noise ratio is non-existent, so why would I ever look at that? Because that's what a rational person does. So it's important that you have some way of plausibly dealing with these. So a ticketing system, where someone is actually assigned to look at them, that can work. The other way I've seen working is a daily email that lists everything that's firing right now, and the on-call has to go through it. But you must have one of these. Otherwise, you're just going to get a pile of email spam that's just going to be leading a blame game at the post-mortem. And that's all I have. So do you have any questions? So the question is, now that Grafana supports alerting for Prometheus, what's the future for Alert Manager? So the thing is that the alerting feature in Grafana is only equivalent, and it's a weaker form of the alerting feature in Prometheus. It hasn't actually replaced any functionality inside Alert Manager, really, which is the deduplication of alerts, the grouping of alerts, the silencing of alerts.
The hard part.
Well, it's not that hard. Actually, the hard part really is the whole high availability stuff. But really, that's just only one part of the alerting thing. Because if you're, as I understand the feature currently in Grafana, it's just that one alert will lead to one notification. And that works fine on small systems, but on large systems, that just causes pager spam. So the question is the Alert Manager standalone? It's a separate binary. The idea is you might have multiple Prometheus servers, and they'll just all talk to it, and Prometheus and the Alert Manager will just deal with that. Because you can imagine if you had two different teams that for whatever reason were producing alerts and you wanted to aggregate those together into a single notification, you kind of need one control point for that. So does the Alert Manager only integrate with Prometheus? The API is documented. It is generally unwise to try and talk to the alert manager yourself, as it works in a certain way that presumes Prometheus is talking to it. Generally, you'll want to actually plumb through Prometheus, which will take care of that for you. But you can talk to it another way. Like, the API is pretty simple. Okay? So the question is, how do you make Alert Manager highly available? The answer is you run multiple alert managers. This is the beta feature at the moment. You get the Prometheus to send to all of them. And we've got a mesh using Weave Mesh that basically they number off. And the first one will send a notification immediately. And then we'll gossip that, hey, I've sent this notification for this alert group. And the next one says, right, I'll wait 5 seconds, and if I don't see it, I'll send that notification and then gossip. The next one's 10 seconds, and so on. So that's how we implement it. So it's taking an AP approach. Because remember, if you have a network partition and there's an alert manager on each side of it, you want both of them trying to talk to PagerDuty. Yeah, lots of people talk, hey, why don't you use Raft or Paxos? It's like, you don't understand the problem space. We want to have both of them alerting, because receiving 2 alerts is better than receiving none when it comes to emergencies, because your network's borked. Right then, thank you very much.